Asset Management Information System. Almost every decision in asset management, whether capital planning, maintenance, or risk analysis, depends on timely, accurate data. Asset Management Information Systems are the tools and software that help collect, store, analyze, and report asset data. Key terminologies: EAM or Enterprise Asset Management, end-to-end management of asset including capital and maintenance planning. CMMS, Computerized Maintenance Management System, focuses on managing maintenance activities, preventing programs and failure histories. GIS or Geographical Information System provides precise spatial mapping of networks such as pipe, valves, and pumps. SCADA or Supervisor Control and Data Acquisition, real-time operational data from equipment and networks. Role of systems in asset management. For EAM, we can see the key role of that is managing assets throughout life cycle linked to investment and maintenance planning. An example for that would be track pipe life, integrate with capital plans and LCC. For CMMS, manage maintenance work, preventive schedules, and failure records. For example, weekly pump inspections, recording repairs and faults. For the GIS, mapping asset locations and analyze positions and performance. An example for that would be displaying pipe locations, valves, pressure zones, and leak points. For the SCADA, real-time condition monitoring of equipment and network would be the key roles, and an example for that would be monitoring pressure, follow reservoir levels, and detect leaks and faults. Importance of data quality. For accurate decision making, data must be correct and complete, timely and up-to-date, integrate across systems. For example, missing pipe age data can skew LCC analysis and lead to poorly timed replacement. Information flow in AMIS, data collection, sensors, operators, contractors, legacy systems. For storage and integration, EAM, CMMS, GIS, SCADA combined. Analysis, calculation like LCC, risk assessments, performance reporting, or KPIs. Decision making, investment planning, maintenance, improvement projects. For feedback and improvement, we can have new data cycles back into the system for continuous refinement. Practical example. Consider a water pipe network. GIS holds exact pipe locations, age, material, and diameter. SCADA monitors pressure, flow, and real-time leaks. CMMS tracks maintenance schedules, failures, and repair history. EAM integrates all this data, runs LCC calculations, and prioritizes replacement or rehabilitation projects. This integrated approach enables early warning before pipe bursts, optimized capital planning, reduced risk, and reliable service. Challenges and solutions. For challenges, we can have incomplete or scattered data, incompatible or siloed systems, staff resistance to new technology. And for solution, we can have standardized data formats, train staff, and define clear procedures. integrated system, for example, link GIS with CMMS, and monitor data quality continuous and improve iteratively. In summary, asset management information system is the backbone of asset management decision making. Without accurate, timely data, LCC, capital planning, and maintenance scheduling would be flawed. Combining EAM, CMMS, GIS, and SCADA provides a powerful platform for monitoring, analysis, and effective decisions. Finally, a question for you. Imagine your pipe age and failure data in CMMS is incomplete, but you need to plan a 5-year investment program. What risks arise and what steps would you recommend to mitigate them? Thanks for watching this video. See you next session.